You know that feeling when you walk into a huge, beautiful building and it just feels perfect? Well, that's not by accident. There's this whole invisible world of engineering happening all around you, literally managing the air you're breathing. Today, we're going to pull back the curtain on that science, and we'll start with a classic example of this hidden challenge.
All right, check this out. This is the main lobby of the TS Suites Hotel. It's absolutely gorgeous, right? It's wide open, the ceilings are incredibly high. From an architectural point of view, it's a showstopper. But for an engineer, this beautiful room is a total nightmare.
And that really gets to the heart of the problem. How in the world do you keep a room this massive and this tall comfortable for everyone without spending an absolute fortune on energy or making it sound like a jet is taking off? Well, the answer is probably not what you think.
To really get the solution, we first have to understand the problem. And it all comes down to some really basic physics, the kind that gets amplified on a huge scale in rooms just like this. We have all heard it, right? Heat rises. And it's totally true. In a super tall space like this lobby, all the hot, stuffy air naturally gathers way up at the ceiling. At the same time, the denser, cooler air sinks and just kind of pools on the floor. This is a classic problem called thermal stratification, and it creates these really distinct and pretty uncomfortable layers of air.
So your first instinct might be, well, just blast the AC. But trying to brute force it like that just creates a whole new set of problems. You're paying a ton of money to chill air that just sits on the floor while the ceiling stays toasty. It's loud, you get these freezing pockets right next to stuffy dead zones with no air movement at all, and the energy bill, absolutely astronomical.
Now this is where the solution gets really, really cool. Instead of trying to fight physics with more power, engineers found a way to work with it. And it all revolves around a totally different kind of fan.
See, we're all used to regular fans, right? They're small, they spin fast, and they create this choppy little breeze right in front of them. The new approach is the exact opposite. Go massive and go slow. Instead of just churning up the air in one tiny spot, these fans create a huge, gentle air current that gets the entire volume of the room moving together. And that brings us to the hero of our story, the HVLS fan. The name really says it all. High volume, low speed. The entire goal is to move a colossal amount of air, but to do it slowly, gently, and with incredible efficiency. And this is it, the AirPro 400. This single piece of technology is designed to solve the lobby's entire problem. And you have to admit, its sleek, modern look fits right in with that grand architectural style.
Okay, so enough with the theory, let's put this thing to the test. We're going back to the TS Suites lobby to see what this technology can actually do in a real-world setting.
So, let's look at the specs for this job. The lobby is 96 square meters, but the ceiling soars up to 10.5 meters. We're talking over 3 stories high. It's a massive volume of air. And the proposed solution to handle all of it? Get this, just one AirPro 400 fan. That's it.
I know, it sounds almost impossible, doesn't it? How could one single fan control the climate in a space that huge? Well, the numbers tell a pretty incredible story.
First up, air movement. This one fan moves 480,000 cubic meters of air every single hour. It's a number that's so big, it's kind of hard to picture, but what it means is it's circulating all the air in that giant lobby over and over again.
And the energy cost to do that? A tiny 0.6 kilowatts. I mean, that is an absurdly small amount of power. It's less than a lot of household appliances use, and yet it's doing the work of a massive, expensive AC system. And what about the noise? Just 38 decibels. To put that in perspective for you, that is literally quieter than a library. In a premium hotel lobby where the ambiance is everything, this is an absolute game changer. You get total air circulation without any noise.
Okay, the numbers are impressive for sure, but what does all that airflow actually look like? Well, thanks to some really advanced simulation, we can actually make this invisible process completely visible.
And here it is, in action. You can just see this massive, gentle loop of air being pulled down from the ceiling and circulated through the entire space. It's not a chaotic storm of wind, it's a single, controlled current that reaches into every single corner.
Now this right here, this is the key. Take a look at this cross-section. The fan creates this powerful yet gentle column of air that travels all the way down from that 10.5-meter-high ceiling directly to the floor. Think of it like a giant, invisible piston made of air.
This whole process has a name. It's called destratification. It's the complete opposite of that stratification problem we talked about earlier. By pushing that trapped hot air down from the ceiling and mixing it all up, the fan completely gets rid of those separate hot and cold layers. It creates one single, uniform, comfortable temperature zone from top to bottom.
And here is the real payoff for anyone in that room. As soon as that column of air hits the floor, it spreads out evenly in every direction. This creates this constant, widespread, gentle breeze that covers the entire floor area. So, no more dead zones, no more stuffy corners. Just total comfort everywhere.
So, what does this all mean? Well, it means we have to completely rethink how we approach comfort and efficiency in our biggest buildings. This isn't just about a better fan. It's about a much smarter way of thinking. So, let's just sum up the results here. You get drastically lower energy costs. You get a silent, premium atmosphere. You get uniform comfort for every single person, with no dead zones. And on top of all that, you get a sleek design and a system that's pretty much maintenance-free. You can see why it's such an elegant solution.
And this idea isn't just for luxury hotels. Not at all. This exact same principle is transforming all kinds of huge spaces. We're talking warehouses, gyms, airports, factories. Any big building with a high ceiling has this exact same physics problem, and this technology solves it beautifully.
Which leads me to a final thought for you. The next time you walk into a massive space, like a convention center, a concert hall, or even a big church, look up and think about the invisible air around you. How could this simple, elegant idea of moving a high volume of air slowly make that space better, more efficient, and way more comfortable? What other spaces in our world could this technology transform?